Hello, everyone. Open any news app today, and you are immediately hit with a future. AI is going to solve climate change. AI is going to cure all diseases. AI is going to take all our jobs next Tuesday. The conversation around AI has hit an unsustainable, frantic pace. It's a hype cycle, so extreme that it can feel impossible to get the clear view of what's real. And here's the most frustrating part for me. The people selling us the most dangerous hype are often the ones who understand the technology the best. That's why I started Humanizing AI. This is not a show about breathless speculations. It is a show for everyone who wants to move past the miracle or apocalypse narrative and truly understand the machine that is being built around us. The goal is simple: to unhype AI and humanize it. And for that purpose, I have the perfect guest for us today. We have Dr. Eric Siegel. Um, Eric is a former Columbia University professor who helps companies deploy machine learning. He's currently co-founder and CEO of Gooder AI. Um, Eric runs machine learning weekly series, and uh, he has written two books, one of which, the Predictive Analytics, I use in my course at NYU. So couldn't think of a better person than Eric for my first guest here. Welcome, Eric.
Thank you, Caesar. It's great to be
Thank you
here.
so
Thanks for
much.
having me.
So yes, let's get it started, right? So let's get it started and let's hit it where I was going with the narrative here. Um, as a former Columbia professor, you taught the core science of AI, the early field defined by 1956 Dartmouth Conference, focused on symbolic AI, though, right? Getting a machine to reason like human being. That's what, the conscious machine and all those kind of things. Your book, Predictive Analytics, which I love, by the way, really focus on statistical prediction. So why this shift? Why do you think this shift is needed from like human conscious like machines to, statistical prediction?
Yeah, well, when I was at Columbia, I taught the grad courses in AI, as you said, including the machine learning course and also the course named artificial intelligence. But even then, I knew that I was kind of buying into a subjective area. It's not very clearly defined, whereas machine learning is well defined and has clear value propositions. Now, that is not necessarily to trash all things AI, because I think the field definitely has value. There's it's an umbrella term that includes technologies, including today's large language models that are so valuable in so many ways. The problem is it's also a particular term that's caught on to have kind of grandiose meaning and imply um, capabilities that I believe are unrealistic, amounting to basically artificial humans. And I'm really concerned about the degree to which it oversells. But as you mentioned, I have been making some noise with articles and videos about my concerns on the hype, enough so that I know the downside uh, to to criticizing the hype. So first and foremost, I'd like to start off this conversation by saying there's a difference between criticizing the hype and the technology. I love the technology. In general, I'm a techno optimist and enthusiast proponent. I think that large language models are unprecedented, amazing, incredible. That doesn't necessarily mean they're going to be nearly as valuable as the hype narrative, but they definitely are valuable when used correctly for sort of reasonably scoped, feasible projects, right? So that's, in a nutshell, the answer to your question. I mean, the move to sort of practical, the antidote to hype is to focus on a concrete, credible value proposition, a use case that actually improves or adds new valuable business operations, and that their performance and their value can be measured. Um, that is to say, creating an artificial human, also most commonly referred to as artificial general intelligence, which is meant to be technology that can do anything or most anything a human can do, or anything valuable that a human can do. There's a few variations there, but it's basically an artificial human. And I don't believe that we are making concrete steps yet towards that as a reality. It may happen in the distant future. But that's sort of the message I believe underlies the hype and has always uh, underlaid the term AI. This idea that we're going to approach human level capabilities in general.
That's great, right? And I think let's dive a little bit more into that hype, right? So because in my view, what generative AI has done is brought AI at the front playing level. Everybody knows about AI now, and that's such a good thing. I mean, 10 years back, when I told people I work in AI, I would have to start from what does that mean? Like, what do you do, right? So you have to really help them understand what AI even meant, and you have to start from the definition of AI. Now, even a kid knows what AI is, which is amazing. I like that. My worry is with the hype that you talked about, right? With the generative AI, the hype is so large that I worry that it's going to harm the field of AI or machine learning in an adverse way, right? And that's my worry, right? So,
Yeah.
and if you think about this, and you have been in the industry for decades and are vocal about, as you said, about this hype of generative AI. And when you look back at AI winters, um, disillusionment about the technology. It could be, technological failure or mismanaged expectations. And I see this as mismanaged expectations, right? So what are your views on that? Do you think, the community is actually doing a disservice by hyping generative AI too much?
Yeah, absolutely. I mean, that's the only reason. Well, there's a broader reason to not to dislike overpromising, right? Especially when you're in a field, and I've been in the field for more than 30 years, and I've seen the hype come and go. Right now, it's about as intensive as I've ever seen it, for sure. But one reason is just that truth matters, right? I mean, there's this feeling that we all have that, if people are out there spouting untruths, uh, that's kind of a problem. But much more concretely, yeah, they'll be held to pay, right? It's not going to be good. That it's called disillusionment, right? That's where the hype cycle goes down, and in the more extreme cases, it's called an AI winter. Um, right? The degree to which there's too much investment, the valuations are too high, all of that is only going to have incur a cost to us in general. It may profit some people in the immediate term, but for the field and for the world, it's
That's
not good.
great. And then, yeah, we completely aligned there. And then this series is about unhyping and bringing people to the reality, right? And let's assume that our audience, some might have enough background to understand what we're talking about when we say machine learning, because you mentioned the term machine learning before, and we have been using AI interchangeably, and people tend to do that these days, right? So um, you are the founder of Machine Learning Week, and this buzzword AI, as you have stated, that's the like more popular narrative these days, right? So, um, for a business leader trying to figure out what they can actually implement, how do you clearly distinguish between machine learning and then this umbrella term of AI, right? I mean, let's help them figure out, what is machine learning, why is it so powerful and important, rather than just AGI and AI and these broader terms that people seem to throw all around.
Yeah, sure. Machine learning is learning from data to predict, essentially. That's the underlying technology, including decision trees, neural networks, ensemble models, that underlies two general categories of use cases, which are predictive AI, also known as predictive analytics, and generative AI. And both of those fields, generative AI and predictive AI, are reasonably well defined, right? If you choose to use the words for them that include AI, there's still some kind of implication that, or a general belief for many people that we're headed towards human level capabilities. But still, it's well defined. In the case of predictive AI, you're predicting who's going to click, buy, lie, or die, commit an act of fraud in order to target any large scale operations, marketing, fraud detection, credit risk management, insurance decisions. And there's a huge long tail, pretty much any existing large scale operation. That's the technology you turn to improve those. The value proposition is very clear. Generative is just that, right? It'll generate new content items, right? That's at the core of it. And what you're predicting in the case of a language model is language. What should be the next word, or more technically token, but that level of detail, while generating a new paragraph, a new document, based on what's been written so far. And by doing that iteratively, the machine's actually writing, but what it writes is pretty good, and represents that it has learned from such an incredibly large amount of training data something about the meaning of words and human thought and lines of reasoning and all this kind of stuff. Something. It's a little bit hard to define the degree to which it's captured human level capabilities, but suffice it to say that the difference between what it can do and what humans can do will become increasingly more clear. And I can make my argument for why that approach is not going to be enough to fully emulate what humans are capable in general. But right now, I'm just trying to answer your
Yep.
questions about the terminology, right? So AI, that term by itself, is subjective. It's a problem if you try to ascribe the word intelligence to a machine. The word intelligence is nothing if not descriptive of humans, a very particular and subjective quality of what people can do. It encompasses a whole bunch of different kinds of capabilities that you could formalize or measure the performance of in different ways. It's sort of all over the place, right? Whereas if you are using a language model, which to a certain degree realizes the concept of AI because it's so seemingly human-like, and it is capable of generating documents and performing other kinds of reasoning tasks if well scoped, if not too taxing, right? To a large degree, that's unprecedented and the kind of thing that only humans could do before. But that alone is not an argument that the technology is progressing towards the whole AI thing. So, okay, going back to just trying to define the terms, large language models can be applied in all sorts of ways. I'll just list off sort of 5 categories of use cases. One is obviously as a chat bot, right? Conversational AI, interacting with it, querying a large number of documents or a small number. Another is just generating content like first drafts, generating first drafts of code. That's called vibe coding. Education applications, interactive tutor, this kind of thing. And then the whole area of data analysis, including kind of data science projects, and there's a certain degree to which that first passes can be automated there. But again, with any of these areas, what's not well defined or even well understood by anybody yet is how to delineate, how to define the difference between how well it can perform in those areas. That is to say, how ambitious or broad a scope the project can be before it starts to have too many errors. And right now, everyone's aware of the errors, and yet because of the AI narrative that's been in the works for decades, including a lot of very fun movies, and because of its seemingly human-like nature, it's this very catchy concept. And you have these very charismatic, typically low-spoken, famous tech bigwigs who, in part motivated, incentivized by their own profit, are delivering these sort of promises of, hey, this thing's going to kind of take over. It's going to be extremely autonomous. Ultimately, if it achieves AGI, you can onboard it like a human employee, let it rip. So when you define what Gen AI is, it's very hard to do that without also putting in a qualifier and saying, these are the kinds of things it can do, but that doesn't mean it can do any of them the way a human will.
I love that, right? And you're so right. And just bringing my chain of thoughts here, based on what you said. Um, predictive analytics, which is machine learning, has been used for decades now already, right? I mean, my first job as an intern was at an edtech company, and we were using machine learning algorithms for predicting text and all those kind of things back in 2013, and even back in 2006. And for you, that's not a long time, but for general public, as I'm speaking, I was writing text classification algorithms, and they have been around for a while now, even at the implementation level, and companies could actually take that and use it. And I've seen that in different companies that like Meta and other places that I worked at. The challenge with generative AI, as you're pointing out for our audience, is, you know, going beyond that first draft that you mentioned, right? I mean, how do you make sure that as reliable as the classical machine learning algorithms that you just mentioned? Can we go deeper into why they're unreliable? Why do you think like it's so difficult to measure them?
Well, you can measure it, right? But that's a new data collection effort, right? That requires human oversight or human evaluation over many cases. Um, uh, the so I'm maybe what you're asking is why is it so difficult to
Yes.
tame them,
Perfect.
right? I mean, so generative AI is much easier to use than predictive AI. Predictive AI has to do with probabilities. We don't have a magic crystal ball, and we never will. We can't, with extremely high confidence, generally predict who's going to click buy, lie, or die, commit an act of fraud, or which satellite's going to run out of battery, or where the best place to drill for oil is. But you can predict better than guessing, and that's generally more than sufficient to drive bottom. So the kinds of operations, the kind of deployments and use cases that are involved with predictive AI are lenient in the sense that it's okay to be wrong. You're just going to be wrong a lot less than if you don't use it, right? So you're playing the business is a numbers game, tipping the odds in our favor. So it's forgiving in that sense. And the value proposition is clear. It's just predicting better than guessing is generally sufficient to drive an improvement to the bottom line impact of how large-scale operations are being conducted, because prediction is the holy grail for making those decisions of who to contact, investigate, incarcerate, set up on a date, or medicate. So, right. Whereas generative AI is right for some uses, you've intrinsically got the human in the loop at all times. Like if I'm using it to create first drafts of every email I send, or of new marketing material, for example, or of code, um, I'm the human in the loop, and I'm looking at it and I'm making an evaluation. So that's great. But the general hype narrative, the promise, the way it's bolstering such huge valuations and investments, the way it's uh, in an unwarranted fashion sucking all the oxygen out of the room away from other initiatives, including predictive AI initiatives, which potentially would, in many cases, deliver higher returns, is because there's a belief it'll be much more autonomous, right? So you can automatically predict which credit card transaction might be fraudulent, and on the fly make an instant, fully autonomous decision about whether to hold that transaction. That's common practice, right? So those predictive types of use cases lend themselves to that. But in the kind of mythology, the overpromising of generative AI, um, you want it to do what a human can do. And if the scope of the project is bigger than something pretty well contained, and we can try to define that, very quickly it's going to have errors too often that makes the whole system not viable for deployment, although it may be incredibly impressive, unprecedented, something we couldn't imagine capable of 5 years ago. If it's making some kinds of grave errors or misbehavior 5% of the time, that can easily be enough to make the whole system not viable, and you can't deploy it. Um, so I'll
Michael,
just stop there. What was your
that's
original
perfect.
question?
That's perfect. I think that's where I was trying to get at was like, we've been reading these recent findings from MIT and other places, how, 95% of
Yeah.
Gen AI cases are failing in industry. And, even at my workplace, I've seen the, going from pilot phase to production phase is very, very difficult for Gen AI because you come across these problems that you haven't before because you just cannot, it, they don't behave the same every time. They are probabilistic. They don't behave the same every time, and that's the tough part, right?
Right.
So yeah, I think you hit the nail there, and we're just trying to figure out, like, you know, um, how are they different, and what's the issue with using them, and how can we actually gain value? And I think what you're getting at is there are certain use cases where their use is actually warranted, right? And maybe focusing on those use cases rather than trying to use Gen AI for everything is what we should be doing, right?
Right. For sure. And I think that we're gonna figure out, maybe a little bit too late for the current bubble, but we're gonna figure out how to harness large language models to pretty aggressively increase the scope of, I mean, not up to the level of general human level capability or wholesale replacement of human roles, But I think that its potential in that 5% success rate reported by MIT that you just mentioned, or 95% of the pilots not getting to production, um, is going to change drastically. So broadly, I'd say predictive versus generative is kind of dogs versus cats, right? In the sense that predictive AI, so generative AI, as I mentioned, it's much easier to use because it's a language model, human language, right? You can interact with it in English or other human languages, but on the other hand, maybe much harder to use well in the sense of delivering concrete, credible, plausible, feasible value. So that's the dogs versus cats thing. Large language models are like the cats. They're much easier to manage, but much more challenging to tame. But I think the taming is the key. And that taming process is a new type of technology endeavor that is just starting to emerge. The need for it is not well advertised yet because the hype thinkers at large, right, and the leaders of the companies selling large language models want to stick to the narrative that it's going to be a panacea. It's going to become so adept, so intelligent, if you want to use that word, that it's sort of a cure-all or a so generally applicable, just do anything on its own. No, what I believe is that to expand the scope of what we can do and the frontier of how language models can apply, the taming process is a semi-automatic one that has to do with developing and continually iterating guardrails, and that the humans must remain permanently in the loop, hopefully to a diminishing degree, to both manage it where guardrails set off flags and something needs to be quarantined and intervened or at least evaluated by a human, and to continually refine, improve those guardrails so the humans needed less and less. So maybe the humans only needed 15% of the time, right? Which is a lot. Humans are a lot more expensive than machines. But with that kind of system, we at least have potential for a more moderately large, ambitious, or highly scoped project to realize, in that case, 85% of the often audacious promise of autonomy, with that human in the loop for the other 15% of the cases, which is a lot better than the system that's just not viable, too many errors, and can't be deployed at all.
That's actually what I've seen with the leaders I've talked to, or even places where I've worked. Especially responsible AI teams always advocate for human in the loop for generative AI, and with that guardrail, putting system production, it's not just even about business value, but also about protecting people. Like if you're working in healthcare, and Gen AI is hallucinating and providing wrong information, there has to be a guardrail to catch it, right? So I love the analogy of cat and dog. By the way, just wanted to mention that, taming the cat, and then I love that analogy. It's really, yeah. Um,
Yeah. Herding
yes.
cats, right? That's a common expression.
Right.
I'm trying to herd
So,
cats.
I want to go back to the intelligence thread that you have been earlier. But before that, let's tackle a foundation issue, right? So for our audience here, um, let's talk about the real foundation, right? When we talk about predictive analytics, or even Gen AI, we have two aspects of data and algorithm. And the success of the current AI boom is often attributed to transformer algorithm and deep learning, which is true. Um,
Mhm.
and what I have seen you do is you emphasize the critical role of data in your business framework, right? And you talk about how improving the data is where you usually get the greatest payoff. Can you help our audience understand that, and maybe business leaders understand why it is important? Because what I'm seeing right now is people are less focused on data and more focused on algorithm and throwing billions of parameters there, right? So what are your viewpoints there?
Well, James Carville led one of Bill Clinton's election campaigns, the reelect committee or something like that. And his catchphrase was, "It's the economy, stupid." And with that focus, he got Bill Clinton elected president of the U.S. But so the catchphrase that comes up here is it's the data stupid, right? But what you're referring to, where I said, the data ends up being more important than the algorithm, is in the context of talking about predictive AI, right? Where it's also known as supervised learning. You need labeled data where the dependent variable is the thing you're trying to learn how to predict. So you've got a bunch of examples where you already know that outcome or behavior, who's going to click buy, lie, or die for each individual case, and it's learning from that and deriving rules or formulas, the weights of a neural network, um, a, an ensemble of decision trees. There's a lot of different ways to do it, in order to put as precise odds for each case as possible, right? So that's where improving the data often is lower hanging fruit. Whereas as you increase the complexity and capabilities of the algorithm and the sort of physical size and complexity of the model that it is deriving, there's diminishing returns. So in that context, data is everything. Now, when you're using generative AI, you're typically using a language model, which you're not creating a new model just for your project, right? You're just using this existing static, already trained and model that's intended to be very general purpose, and it'll be used across a whole bunch of different kinds of projects for different companies and different use cases, right? That's the intent, or that's the sort of typical paradigm. But in the context of what I just said a minute ago, where it's like we need this system, this reliability layer that's going to involve a continually evolving set of guardrails, and the management and implementation of those guardrails might itself also be a large language model. In that case, AI is healing itself, but only to a certain degree, right? It's only one arsenal within the overall process of guardrails. It's not a panacea, including its inability to completely cure its own problems, right? So one way or another, there's a whole new um, odds game, number crunching game, playing the numbers, just like you're playing the numbers when you're deciding which transaction to block or audit as potentially fraud, who to contact, invest in $2 to send a brochure for marketing, which application for credit to authorize. Likewise, in the large scale deployment or hopeful deployment of a large language model or some system that employs one, you've got a whole new numbers game all over again, which is how often is it going to be incorrect or otherwise problematic, and how do you try to detect and flag those cases most likely to be so you can funnel them, so you can learn how to intercept them off by expanding those guardrails or funneled off to humans, or some combination of the two, right? So all of a sudden, you're playing a whole new numbers game, and in fact, predictive AI does apply, or can. So you can apply a predictive layer and learn from it. And in that case, all over again, it's only the data that really matters. You're standing on the shoulders of giants. You're trying to make use of this awesome pre-existing large language model, which has so much clear or apparent potential for the business problem you're trying to solve, except it's just wrong or problematic or fails in one way or another too darn often. So, but if you get the numbers on that over some large number of cases, and you have enough investment humans in the loop to label those cases and then learn quantitatively, all of a sudden you're performing predictive AI, you're performing enterprise machine learning on top of generative AI, and it's a hybrid approach. And so once again, it's the data stupid.
Awesome, awesome. Thank you so much. And yeah, being what we did today, before we move on to that intelligence thread, which I really want to dive a little deeper into, for our audience, we talked about, how when we say AI, people are mostly talking about machine learning, and we should though understand difference between two kinds of machine learning that Eric was talking about. One is the predictive machine learning versus generative, right? And then when the context that AI is talked about these days is the generative, the large language models are a part kind of a generative AI, right? So just wanted to make sure that people understand that is that algorithm part, and then there's data part. And data powers all of these things, right? And then I love that analogy of maybe
Yeah.
having something on top of generative AI models to make them perform better. Right? And then I think I think that's where
Yeah.
the future is. And And this is a shameless plug, but that's what Human Lens, my company, tries to do. Is
Mhm.
we are a security layer on top of all of these AI, where we are using, looking at the data to see how accurate they are, whether there is bias, right? So these will be topics for future. And I know you write about bias quite a bit. If we have time today, maybe we can dive into that a little bit, so that we can set up a ground for stays for the next episode here. But let's get back to that in measuring of intelligence you mentioned, right? So I noticed Alan Turing behind you, and Turing came up with the yeah, right there, and he came up with this technique of s- you know uh, you know uh, testing intelligence, let's say, in one way, right? And it was just called a Turing test, right? So could we do something like Turing test to now? And would you say large language models would pass Turing test with the capabilities that they have right now?
No, they definitely wouldn't. I mean, first of all, the Turing test is a great philosophical point, and it's really just meant as a thought experiment. I mean, you can conduct it, but there's a limited utility in conducting it. It's just, you know, it's the idea is if it walks like a duck and talks like a duck, it's a duck, right? So if the machine, if people on average statistically can't tell the difference between chatting with a machine versus chatting with a human, because the machine emulates or tricks or otherwise, blurs the distinction for humans, then from the human perspective, what's the difference, right? Oh, so then let's use the word intelligent because it's a quasi-human, right? That's the idea. So there's a bunch of problems with that as the benchmark for whatever for our goal, right? First of all, what's the utility in tricking people that they're chatting with if there's something meant, if there's some way to define AI, certainly the field's meant to have utilitarian or useful value, right? So tricking people. The other thing is fool me once, right? That expression. Um, Although you might have a system that passes the Turing test, it's been done as totally viable in part by sort of cleverly nonlinear, seemingly random chains of thoughts that you think, oh, only a human would be that strange or odd or what have you. These kinds of essentially tricks. The problem is that people will become wise to the trickery. So you might pass it over some statistically significant number of human subjects on one occasion, but once everyone sort of gets wise to how it works, they won't be fooled again, right? But still, the real question is, how do you define? I mean, it's an attempt from a philosophical standpoint to define intelligence in a way that you could measure, so that you could see whether a machine is approaching it. Um, but defining intelligence, and in that way also defining the field of AI, is a fool's errand. The problem is that there is no um, satisfactory definition to define AI other than artificial human, otherwise known as AGI, right? Which is sort of it's a cop out. It's the whole enchilada. It's like, well, it's a virtual human. If it can do everything a human can do, which obviously would be very hard to measure, right? You'd actually have to let it run a corporation for 10 years and see how well the corporation does, right? There's some practical problems with actually measuring it. But in any case, short of just that whole enchilada of AGI, any other way to define it either um, uh, is subjective or is circular, which is very common, like AI is trying to get machines to be intelligent. So it's either subjective or circular, in which case ill-defined. How do you pursue an engineering goal is not well-defined, or it's circular, as I mentioned, or it fails to fulfill the spirit of the term AI, right? Which is this sort of amazing, almost human level thing, right? So once we get to play chess, right, which was considered AI, now it's like, okay, play chess. That's not really what we meant by AI, right? And once we get to the point where cars are fully autonomous in general, um, which could be a few decades, by the way. But it's on the horizon and it's important. No one's going to say we've solved AI once that happens either, right? So there's this real definitional problem, and the real problem is just trying to use the word intelligence, which, as I mentioned, is so subjective, and uh, um, and human specific. Um, in the first place. So is it a proper goal? On the other hand, whether the thing will essentially reach general human level capabilities or even beyond, um, you know, people claim it will. There's a pretty broad belief base that it will. That's unfalsifiable, right? It's as unfalsifiable as me making a claim that, within 10 years, aliens from Pluto are definitely going to invade Earth,
Mhm.
right? It's unfalsifiable. There's no way to prove it false, but it should be questioned as much as any other outlandish, right? I mean, strong claims require strong evidence. But so now that we've sort of everything you've guided me here, and I'm really happy to be on your opening episode where you kind of defined the groundwork and the landscape of AI and defined all the terms and such. And now that we've done that, and sort of both of us are clearly on the same page as far as the degree to which there's overpromising and hype taking place. But I also think that the last remaining, maybe most important thing, although I know you may have other questions, but maybe the most important thing remaining um, is to try to help people who are intrinsically believers. And because it's a very seductive narrative and always has been since the 50s, right? The vast majority of historical podcast episodes and books and such, perhaps all of them, except for one book that I read, there's one exception that I can think of, talk about the original inception of the term, a coining of the term AI in the 50s at that Dartmouth event with reverence, right? It's very rare to look back at that and see it as the seeding of a mind virus that's seductive and misleads people, right? But so it's very seductive. And what makes it even more seductive is how seemingly human-like, unprecedented, amazing large language models are, and that the most famous, wealthy people in the world, most of them are giving credence to the idea that we're rapidly approaching AGI. So the whole thing is extremely seductive. So what I'd say is maybe the most important thing remaining is to try to offer a bit more specific counter argument. Again, I think that the responsibility to make the argument is in the person making such a strong claim, but I can formulate the beginnings of an argument for why it's outlandish to say that we're making concrete and quick progress towards AGI. So let me give that a little spin, and then I want to hear whether you agree with my perspective, and also if you have anything to add for your listeners, right? As far as like, how do you, because people are believers and they're very entrenched. Um, uh, but in a nutshell, let me put it this way. When you learn from, millions and millions of billions of documents, as large language models do, um, it's all of that data that it's learning from, it represents human behavior, right? Just as you're predicting which customer is going to cancel, you're learning from historical human behavior who ended up canceling or 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 defecting as a customer in the past. Similarly, the human behavior we're learning from with a large language model is what word was written next, essentially. Human writing. Human writing is very meaningful human behavior, and there's a lot of it to learn from. And obviously, you can get a lot from that, right? In that sense, it's emergent, right? Technically, it's only trying to predict what should the next word be, but emergently, it ends up being able to do things like answer multiple choice questions really well and all sorts of stuff, right? So then the big question is, how much of the human mind can be reverse engineered by learning from that extensive, albeit limited, representation of human behavior? Human writing doesn't represent all human behavior. There's nothing about what's happening inside the brain cells, right? There's nothing about the physical movement, although that's something to a certain degree learning from video, but it's still a relatively limited scope of human behavior. How much of the actual human mind, which evolved over so many years on this in this very particular environment of Earth, right? How much can be reverse engineered from that data? My opinion would be a lot, but there's a ceiling.
That's a great point. That's a great point. I think I'll add a few things there. It's one, as a student of generative linguistics, and like the Chomsky style of linguistics, you know, we believe language is uh, window to your mind, right? So, and that's, I think some of this is coming from that belief that, like, I mean, if you really, really understand how languages work, there's a great chance that you can actually start understanding how your mind works.
Mhm.
To your point, there might be a ceiling, but there's a deeper belief in among the linguists and others that there's something there. There's something there that can help you understand your mind better if you understand language, right? So, um, so I would say yes, there might be some truth. My problem comes from the architecture of the design that we have right now, the algorithms, right? So, even let's say that, okay, if you understand language, but we are following connectionist with this idea of neural network, and because mine seemingly for some people work like that, and maybe let's model it like that, and then we will figure it out because maybe that's the architecture that we have. But that's not a proven fact, right? That's not a philosophy. It's in the philosophy of mind that that there could be different ways of understanding mind, and this was one of it, and we chose that. But I think even the leading researchers, some of them, not well, all of them, have given away the idea that, okay, neural network is the right way to go here, or the large language model, the current way of large language model, should be chosen for the proper form of AI that they are chasing, right? So if you look at the head of science for Meta, he's one of the Turing Award winners, and we are following his footsteps for AI. Even I think he is openly now saying that large language modeling is not the right way to do it. So, I mean, I think there's a to your point, I agree. I agree that there's a ceiling, and just throwing lots of language data to a model trying to understand might not be the right way to do. But I'm also saying that there might be the whole architectural problem where uh, maybe that's not how our mind functions, and we're following the wrong thread here to understand how our mind works, right? So
So I'd like to address both points you made and ask kind of questions. First of all, I think you've studied more linguistics than I did. I got into it in college, and then in grad school, I was in machine learning research, but also natural language processing, which was generally referred. I was in the computational linguistics group. Um, so, but there's a difference between computational linguistics and linguistics as a broad field. But I think my interest, it was maybe kind of nerdy, but I was kind of like, linguistics is cool. Like, I would say, I would say, take the word fantastic. I would say fan flippin' tastic, but I wouldn't say fantas flipping tick, right? And you can try it to different words, and the rule that but you don't know, is that you're going to insert flipping before the accented syllable. That turns out to be the rules. You can try it out. Oh yeah, that rule is embedded in my brain. I didn't even know. So it again, as you said, linguistics is reflecting the mind. But within sort of the linguistics as a proper field, which I think you've studied more, you know, uh, language is a window to your mind. That philosophy. Would I be right to assume, though, that linguists or that the community of linguists wouldn't necessarily say it's a window to your entire mind, but just sort of a somewhat
I would think
revealing
so.
window?
I would think so. I mean, and I might be wrong because I haven't been doing linguistics for a long time now. I was a grad student. I was a PhD
Yeah.
student. I dropped out. But and to your point, and it's fantastic field, right? Um, and my concentration, like my research, was more in phonotactics, or phonology being study of sounds, and phonotactics being how sounds combine to each other in different worlds languages, and what are the limitations, and same thing as the word example you gave. Our human mind makes up sound um, to
Mm.
makes up sound sometimes to just adhere to what they are tuned for. And what I mean by that is, if certain sound doesn't exist, certain combinations don't exist in your language, you try to break it apart and insert a vowel, right? So in Nepali, let's say word initial st doesn't exist in my language, right? Then I would just insert a vowel, ist, like rather than stick, I would say istic. And in Japanese, they hear like they have done, studies where they actually measured the brain frequencies, and they saw people were hearing vowels that didn't even exist, right? So mind is amazing, and linguistics seems to be a window to understand that for sure. Um, but yeah, that's a separate topic. We can start talking about it all day if we do that. And I know we are coming to the end here, Eric, and what I would say is,
Well, I just reflect that I think that you and I, even though we're both concerned about the degree to which there's overpromising and that there's this lack of realism and feasibility to near term artificial general intelligence, at the same time, I think that both of us are giving a more balanced view than a lot. There's more and more people out there making a lot of noise against the hype who are really just
yeah,
trashing large language models. They're like, it's all baloney, it's useless, it hallucinates, and they're just they're not lending any credence to what it's actually been able to do or to the very real value propositions that it appears that are feasible in the near and medium term. So I think that that's refreshing too, because there's not a lot of really
yeah, I
balanced
agree.
view of
And
this stuff.
I think that they're doing disservice to themselves and the community. As I'm starting this company now, right? I mean, we're just three co-founders. All of us write code, and we are literally using large language right now for coding. And like you said, there's human in the loop. I haven't like I've been a manager for for a decade now, so I've been hands-on coding. But this is bringing back all the old memories, the muscle memory. I can look at the code. I built the website, which I hadn't done since
Yeah,
2003, probably, right? So, these are blessings, in disguise. Like you can actually use these tools to
sure,
make yourself more productive, but do it responsibly. Just do it more
sure.
responsibly and know the limitations. And
Yeah,
that's what we'll do. And thank you for saying that. I think like that's what we need, the balanced perspective of AI. And
yeah.
the value is tremendous. Like we cannot ignore the value that machine learning and natural language processing can bring to this.
And balance isn't boring, right? You can still make a big noise about how ridiculous the hype is, and you can still get very excited about how awesome large language models are, right? You can still have fun in both directions. Balance doesn't mean you're
Exactly,
moderate in
exactly.
both.
Okay, and this is the perfect segue to next episode. And thank you so much for coming here. We'll talk about that balance for my audience. We'll talk about risks of AI. We'll talk about compliance landscape. We'll talk about more in-depth analysis of large language model and its nitty and gritty and like how it works. But all of that for future episodes. And I just couldn't be more thankful to Eric for showing up here and having this amazing
Sure.
conversation with me. Thank you so much for taking the time from your busy
Yeah,
calendar.
my pleasure, Caesar.
Thank you so
Thanks so
much.
much for having me.